Grignard. What kind of word is that? Is it some kind of French insult? Out of my face, you Grignard! No, Grignard is someone's name. Specifically, it's the name of the French chemist Victor Grignard, who won the Nobel Prize in 1912 for discovering the reaction that would be named after him. And this reaction is what we're going to be talking about today. So, allons-y, mes amis. Alright, please excuse me if my French isn't all that good. Don't worry, I speak the language of chemistry so much better. Okay, so what's the Grignard reaction? The Grignard reaction is another way to make alcohols. However, it's a bit different from other reactions for producing alcohols. I mean, that's why Monsieur Grignard got a Nobel Prize for it after all. So we've already learned how to make carbonyl groups to make alcohols. If you haven't seen the video on that yet, you should probably go and check it out. This is the reaction where you take a ketone or an aldehyde and transform it into whatever acid you want. The result is the specific alcohol you're trying to get. So, what makes the Grignard reaction better? It forms new CC bonds for starters. See, that means we can take a small alcohol and make a bigger or more complex one out of it. Now that's the kind of thing you get a Nobel Prize for. So, how do we do this? Well, first you've got to know about Grignard reagents. A Grignard reagent is an organomagnesium compound. So, a magnesium bonded to an organic residue. And then we're also going to slap a halogen on that magnesium. Why, you ask? Halogens are super electronegative. That means our super electropositive magnesium is going to get a positive charge. If you're wondering why that's important, just hold on. The organic residue in the molecule is more electronegative than the magnesium, which means it gets very electron dense. So, one very important part of a Grignard reaction is the Grignard reagent, an organomagnesium bond with a partially positive charged magnesium and a partially negatively charged organic residue. Okay, so let's get this reaction going. I'm already getting hot under the collar. More like hot and charged. Well, especially charged actually. We're going to go ahead and start with our reagent, which we're going to allow to react with a carbonyl compound, let's say a ketone. How about acetone? Okay, so the nucleophilic carbon atom of the reagent's organic residue, the carbanion, attacks the ketone's central C atom with its bonding electron pair. It's positively charged, so it's just asking to be attacked. An electron pair on the oxygen opens up at the top. At the same time, the oxygen takes over the magnesium and the halogen, forming a metal alkoxide. And there you have step 1 of the reaction. A Grignard reagent and a carbonyl form a metal alkoxide. So, what happens next? Well, we add a little bit of dilute acid to our metal alkoxide, which hydrolyzes the metal-oxygen bond. In English, that means the magnesium and the halogen are chemically separated from the oxygen by water and H3O+ ions. Both of them are released into the solvent as ions. The remaining alkoxide, this bit right here, without any metal, now gets an H+ from the acidic solvent. And there you go, a new tertiary alcohol. So, in 2 steps, we sent the metal along with the halogen off into the solvent and protonated the alkoxide. And this gives us a new alcohol. Okay, so we can totally see the mechanism at work here, right? Yeah, not entirely. The actual mechanism is a lot more complicated. But you'll see that when you study chemistry in college. Monsieur Grignard didn't get that Nobel Prize for nothing. The important thing is to be aware that everything happens pretty quickly in step 1, and the compounds involved in the reaction don't get split up. The other thing is that this ends up creating a relatively complex transition state. Before we're done, we want to show you all the things you can do with this reaction. So, the Grignard reagent and formaldehyde gives us a primary alcohol. With all the other aldehydes, we get secondary alcohols. Ketones give us tertiary alcohols. 2 units of reagent plus formic acid ester gives us a secondary alcohol, and all other esters plus 2 units of reagent gives us a tertiary alcohol. Okay, here's what we need to remember. The Grignard reaction is so interesting because it forms new CC bonds and allows the formation of more complex alcohols. We start by reacting a Grignard reagent with a carbonyl compound. And with various compounds, we're able to get primary, secondary or tertiary alcohols. Alright then, now you know all the important reactions for making alcohols. Now all you need to know is what these alcohols do after they're made. To find out, just keep clicking through our playlist. Have fun!